1,776 feet. The year of American independence turned into a height. That is where this story ends, on a spring morning in the sky above Lower Manhattan, as ironworkers bolt the final piece of steel into place. But to understand how they got there, we have to go back to the very bottom. To a hole in the ground where two of the most famous towers in the world once stood. A few weeks ago, we showed you how the original World Trade Center was built. 8 cranes shipped across the ocean from Australia. Cranes that climbed the towers from the inside and hauled the steel upward floor by floor while the country watched. Today, we want to show you what changed in the decades that followed, and how the new One World Trade Center rose from the same ground. After the tragic collapse of the towers, the tallest building in the Western Hemisphere had to be raised on the footprint of what was lost. And when the work finally began, the very same Australian company that had lifted the first towers came back. Only this time, 2 cranes would do the work that once took 8. This is the story of the machines that built One World Trade Center. The concrete, stronger than solid rock. The pumps that pushed it higher than concrete had ever gone in the Americas. The spire that almost cost America its tallest building over a decision to save $20 million. And the men who stood a quarter of a mile in the air to put it there. We spent weeks pulling this together from the engineers who lived it. And it is one of the most overlooked construction stories of our time. Stay with us, because we are going to build this tower the way it was actually built, from the bedrock to the beacon. Let us begin where every skyscraper begins, underground. Before a single crane arrived, the engineers faced a problem hardly anyone ever thinks about. The new tower could not simply be dropped onto empty ground. Underneath the site, in the lowest levels of the old complex, ran a set of commuter train tracks. These were the path tracks, carrying tens of thousands of people every day between New Jersey and Manhattan. And here is the part that makes this build so extraordinary. Those trains never stopped running. Not for a week, not for a day. While the tallest tower in the country was being built directly on top of them, the trains kept rolling underneath, full of passengers who had no idea what was rising above their heads. To build over live railroad tracks, the engineers designed a network of underground steel transfer trusses. Think of these as enormous steel bridges buried beneath the building, whose only job is to carry the impossible weight above and hand it around the train tunnels into solid ground on either side. The foundation reaches roughly 70 feet down through 4 underground levels. And at the very bottom, the tower rests on spread footings anchored into Manhattan schist, the ancient bedrock beneath the island. That bedrock is the reason New York has skyscrapers at all. In some places, the engineers found rock that could carry 60 tons on every square foot. In select locations, they cut deeper, into stone strong enough to bear more than 100 tons per square foot. And to keep the finished tower from ever being pushed over by the wind, they drove rock anchors 80 feet into the bedrock, steel tendons reaching into the earth to hold the building down against the sky. The engineers who worked out how a tower this tall could stand on a site this complicated were from Muser Rutledge, a firm that has quietly solved New York foundation problems for generations. Before we go any further, if you enjoy the way we take these builds apart from the ground up, the best thing you can do is subscribe and tap the like button. It helps more people find these films, and it keeps us making them. Now, if you have watched our films before, you know we do not skip the details that separate a good story from the truth. And there is a detail here that ties the 2 towers together in a way almost nobody talks about. When the original World Trade Center was built in the late 1960s, its engineers faced a different version of the same underground problem. The site sat on old landfill, at the edge of where the Hudson River once reached. So they built something legendary among engineers. A giant waterproof wall, 3 feet thick, all the way around the site, sunk 70 feet into the bedrock. Workers filled the trench with a heavy mud called slurry to hold the walls open as they dug, then lowered in steel cages and poured the concrete. This wall held back the river, and engineers gave it a nickname that stuck for half a century. They called it the bathtub. On the morning the towers came down, almost everything at the site was destroyed, but the bathtub held. That great slurry wall, poured by hand in the 1960s, survived and kept the Hudson River out of the wound in Lower Manhattan. And when the time came to build the new tower, the engineers made a decision that connects the two buildings forever. They did not tear the old wall down. They saved it and reinforced it. Behind sections of the original wall, they built new concrete piers, tied into the earth with roughly 1,000 steel cable anchors, and in places, added a new inner liner wall as much as 7 feet thick, standing in front of the old one like a second line of defense against the water. The old bathtub, the one that survived the worst day, became part of the foundation of the tower that replaced the towers. If you visit the museum on the site today, you can stand in front of a section of that original slurry wall, still holding, still doing its job. It is, in the most literal sense, the one piece of the story both towers share. And it is the perfect place to understand what changed between the two builds. The old towers were raised in a hurry, in an age when danger was simply part of the job. The new tower would be built in a different world, one obsessed with getting every man home alive. That obsession would shape every machine, every method, and every decision from this point up. And it started the moment the cranes arrived. In 2006, 2 tower cranes were erected at the site, and their arrival closed a loop that had been open for almost 40 years. They were built by Favelle Favco, an Australian crane company. That name should sound familiar, because it is the same company whose 8 kangaroo cranes had climbed the original Twin Towers back in the 1960s. The Australians had come back to New York, but the cranes that returned were not the cranes that had left. The originals were the STD 2700, a design so new the company had to build it at double the size of anything it had ever attempted. 8 of them replaced 12 slow, old-fashioned derricks to raise the first towers. The new machines were the M760D, diesel hydraulic luffing cranes powered by Caterpillar engines, so much more capable that the entire tower would be built with just 2 of them. Each one could hoist 64 tons, and each one climbed the building as it grew, exactly the way the kangaroo cranes had, jacking itself up floor by floor on a hydraulic climbing system fixed to the structure. The cranes were owned by a New York crane man named James Lama, who rented them to the lead contractor. And here is a small piece of history that closes another loop. The lead contractor on the new tower was Tishman, which had also been the lead contractor on the original Twin Towers. The same builder, the same crane company, the same footprint, 40 years apart. If you were looking for a single thread tying the old world to the new one, it is standing right there on the skyline, painted in crane yellow. Getting those cranes to work took real cleverness, because the building was going up on ground with almost no room to breathe. On a normal site, you have space to lay down steel, stage materials, and let trucks turn around. Here, there was almost none. The tower sat in one corner of a 16-acre site where 7 other major projects were being built at the same time, hemmed in by city streets and by the live train tunnels below. There was nowhere to store anything. So the contractor did something that tells you everything about how modern construction works. They planned the whole build like a freight train on a schedule. One of the project executives described it exactly that way, as a vertical freight train, and said his team micromanaged every delivery down to the hour. Steel arrived at night, trucked into Lower Manhattan under police escort so it could be lifted straight off the trailer into the building without ever being set down. No warehouse, no yard. The material showed up when the crane was ready for it, and not a moment before. And then there was the strangest structure on the whole job, one of our favorite details in this story. In the hollow core of the rising tower, the builders stacked 36 shipping containers on top of one another. Inside them, they put lockers, restrooms, and even a sandwich shop, so the workers never had to leave the building to eat or take a break. Sending men down to the street and back would have wasted hours every day and jammed the hoists needed to move materials. So they brought the break room up into the sky. But those containers did something even smarter than feeding the crew. They were engineered to double as bracing for the steel frame, and their roof shielded the concrete workers below from anything that might fall from the iron workers above. One structure, 3 jobs at once. That is the kind of thinking that built this tower. Now let us talk about the steel itself, because the way it went up broke with tradition in a way that surprised even veteran New York builders. The tower is a hybrid. At its heart is a massive core of reinforced concrete, wrapped in a frame of structural steel. Before the tragic collapse of the towers, tall office buildings in New York were almost always steel frames. This tower combined the two, a concrete spine for strength and protection, and a steel perimeter to hold the wide-open floors tenants wanted. The steel came from far away in enormous pieces. The great columns that ring the base were rolled from plate produced by the steelmaker ArcelorMittal in a mill in Luxembourg, shipped across the Atlantic, and fabricated in yards in New Jersey and Quebec. One of the largest columns placed early on measured 60 feet long and weighed 70 tons. A single column. Some of the largest continuous concrete pours on record were happening on the same days that some of the largest steel members ever fabricated were being swung into place, side by side, in the middle of a working city. Here is what broke tradition. On a building with a concrete core, the normal way is to build the core first and let the steel chase it upward. On this tower, the builders flipped it. The steel rose first, climbing ahead of the concrete, and the core was built up behind it. The contractor pioneered this steel-first sequence, and the reasoning was simple. It was faster, but it created a fascinating arrangement in the sky. The ironworkers were up top, setting steel. The concrete crews worked below them. Inside the frame, the ironworkers had already built. And that turned out to be far safer, because each group was protected by the structure the other had already put in place. Which brings us to the biggest difference between how the old towers were built and how this one was. And it is not about cranes or concrete at all. It is about the men. When the original World Trade Center went up, ironworkers walked the naked beams the old way, hundreds of feet up with nothing beneath them but the street. That was simply how the job was done, and the human cost was terrible. 60 people were killed during the construction of the original Twin Towers. 60. On this build, the contractor did something never done on a steel skyscraper in New York City before. They wrapped the top of the rising tower in what they called a cocoon. It was a lightweight steel and netting system, 2 stories tall, that traveled up with the work and draped down over the floors below, catching anything or anyone that fell. Hanging platforms let the men work in the open air without balancing on bare steel. Through the entire structural construction of the tower, the lead contractor reported no deaths and no major injuries. We will come back to the full safety story later, because the record is not perfectly clean, and we will not pretend it is. But the contrast is real. 60 lives on the old towers, a build engineered from the netting up so that number would never come again. That was the promise of this tower. Now we had to fill it with the strongest concrete New York had ever seen. To hold up a tower this tall and this slender, the engineers needed concrete unlike anything the city had ever used. And what they created is, for our money, the most astonishing material story in this entire build. Ordinary building concrete is rated at around 3,000 or 4,000 pounds per square inch, a measure of how much pressure it can take before it fails. The strongest concrete New York had ever poured before this project was rated at 12,000. For the core of the new tower, the engineers specified 14,000. The lead structural engineer put it in words that stuck with us. He said the concrete in that core was much stronger than any rock you could find. Read that again. They built the spine of this skyscraper out of a man-made stone stronger than the bedrock it stands on. And when they tested it, some samples came back even higher, reaching 17 and even 18,000 pounds per square inch. That strength let the engineers make the core walls thinner, freeing up precious floor space to rent, while still carrying the staggering weight and standing firm against the wind. The columns were graded like a staircase. The lowest floors got the 14,000 pound mix. Higher up, where the loads were lighter, the concrete stepped down to 12,000, then 10,000, then lower near the top. But concrete this strong is temperamental, and this is where the real craft came in. When concrete cures, it heats up from the inside through a chemical reaction, and the stronger the mix, the more heat it makes. If the core of a thick wall gets too hot, above roughly 160 degrees, the concrete can be permanently weakened. The engineers were pouring walls up to 6 feet thick. Left alone, the heart of those walls would have cooked past the safe limit and lost the very strength they were poured for. So the crews fought the heat, with tricks that sound almost homemade for a project this advanced. They poured at night, when the city was cooler. They dumped huge amounts of ice into the mix in place of some of the water, chilling it from the start, so it had more room to warm before it reached the danger point. And they buried tiny radio tags inside the fresh walls, sensors that reported the temperature deep inside the concrete as it cured. So the crews knew exactly when a wall had hardened enough to strip the forms and keep moving. Ice in the mix and radio tags in the walls, all to tame a stone stronger than rock. And now, for the record, we think deserves to be far more famous than it is. That heavy concrete had to be lifted from the ground all the way to the top. Pushing concrete up through a pipe is one of the hardest things you can ask a pump to do, and the taller the building, the harder it gets, because the machine fights gravity and friction the whole way. On many tall buildings, the crews pump the concrete partway up to a station, remix it, and pump again from there. On this tower, they did not. Using stationary high-pressure pumps built by the German company Schwing, feeding tall placing booms mounted on the climbing forms, they pushed the concrete from the ground to the top in a single continuous lift. 103 stories in one shot. It was, according to the trade press that covered it, the highest elevation concrete had ever been pumped anywhere in the Americas. We want to pause on one detail, because we know some of you follow this closely. You will sometimes hear that the record-breaking pump on this project was a Putzmeister. It was not. Putzmeister set the great vertical pumping record on the Burj Khalifa in Dubai. The pumps that pushed the concrete up One World Trade Center were as Schwing. 2 different machines, 2 different records, and they get mixed up constantly. On this tower, it was Schwing that made the climb. A quick word here, because films like this take days of digging through old engineering journals and trade records to get right. If you would like to help us keep making them, you can support us with a small donation through the link on our channel. Even a cup of coffee's worth genuinely helps fund the next one. The men who poured that concrete were led by a contractor named Colavino, and the man who ran the work described it the way only a builder would. He said the steel is always in the way when you are concreting, and that his crews could pour on 3 floors in a single day, which meant the pumps simply had to perform every day without fail. Some days they placed more than 100 cubic yards an hour, pushing it up 400 feet of pipe at pressures that would tear an ordinary system apart. Floor after floor, the tower climbed. But a building does not rise on machines alone. It rises on the men who ride those machines and walk that steel. And on this tower, some of those men carried a story that runs deeper into American history than almost anything else in this film. For nearly 100 years, the high steel of New York City has been walked by Mohawk ironworkers from a community called Kahanawake, near Montreal. Going back to the 1920s, they earned a reputation as the men who could work the narrow beams hundreds of feet up without fear. They walked the steel of the Empire State Building, the George Washington Bridge, the Chrysler Building, and they walked the original World Trade Center. Their people called them the Skywalkers. When the new tower rose, they came back. A Mohawk ironworker named Joe McCummer worked on One World Trade Center, and his grandfather's last job had been the original World Trade Center. 2 generations of the same family, working the same patch of sky, on the tower, and on the tower that replaced it. Another 3rd generation Kanawake ironworker, John McGowan, spent 4 years on the building and helped set up the cameras on the roof for the moment we are building toward. He said it was a great honor to bring the height back to New York. Only a handful of these men were on the job, but they carried a lineage that stretches across every famous skyline in the city. Some of the hands that raised that tower belonged to the same families that raised the skyline around it. By the summer of 2012, the steel was reaching its full height, and a single beam was about to carry a nation's worth of feeling to the very top. On the 2nd of August, 2012, high on the unfinished tower, a crew of ironworkers connected a single steel beam onto the 104th floor. This beam was different from the thousands before it. It was painted white and covered in signatures. Workers, family members, and visitors had signed it, and across it was written a line that had become a kind of promise. We remember, we rebuild, we come back stronger. 2 ironworkers released the cables that held it, and the last piece of the tower's structural steel was locked into place. A supervisor said the writing on that beam came from the heart. After all the concrete and all the cranes, the frame was finally complete. Because the steel frame was not the end of the height, the tower still had to reach its symbolic number, and that number is the whole reason this building looks the way it does. 1,776 feet. The year of American independence turned into a height you could see from 30 miles away. The main roof of the tower sits at 1,368 feet, and that is not an accident either. That was the exact height of the original Twin Towers, matched on purpose, a quiet salute, built into the steel. But to climb from that roof up to 1776, the tower needed a spire. The spire was a machine of its own. It stood 408 feet tall, weighed 758 tons, and was built in pieces in Quebec, then floated to New York by barge, and trucked to the site in the dead of night. Getting it up was one of the most delicate lifts of the whole project. First, a 600-ton mobile crane lifted the spire sections off the trailers to a staging area. Then the tower cranes, the same Australian Favco cranes that had been on this job since it was a hole in the ground, were re-rigged for their final task. The crew had to freestand one of those cranes a full 180 feet above a building already 1,600 feet tall. The crane owner said it plainly. He said this was a really tough job. If you can imagine freestanding a tower crane 180 feet on top of a 1,600-foot-high building. To reach that height, the riggers needed a new winch drum carrying 3,500 feet of cable. One crane hoisted the sections up. The second set them in place. The first piece of the spire went up in January of 2013, and on the 10th of May, the final section was bolted into place, and One World Trade Center officially reached 1,776 feet. It became the tallest building in the Western Hemisphere. The head of construction at the site said the finished tower would tell people across the region and around the world that the city was back better than ever. If you are still with us, thank you, and please consider subscribing so these stories keep finding you. Now let us get to the part almost no one knows, the decision that nearly cost this tower its crown. But here is the part almost no one knows, and the reason we called this a gamble. That number, 1776, was very nearly lost over a decision to save money. In the original design, the spire was meant to be wrapped in a sculpted shell of fiberglass and steel called a radome. It was that sculpted spire, integrated into the design, that made the mast count as part of the building. But the covering was expensive, and to trim the budget, the decision was made to strip it away and leave the mast bare. Even the building's own lead designer admitted that without its covering, the thing on top now looked less like an architectural spire and more like an exposed antenna with equipment bolted to it. And that mattered enormously, because of an old and surprisingly bitter rule in the world of tall buildings. When the official body that ranks the world's tallest buildings measures a tower, a true spire counts toward the height. A mere antenna does not. So a question that sounds almost silly suddenly had a national title riding on it. Was the bare mast a spire or an antenna? If they called it an antenna, the tower's official height would drop from 1776 down to 1,368 feet, the height of the roof. And at that height, it would no longer be the tallest building in America. It would fall behind the Willis Tower in Chicago, the old Sears Tower, and lose the crown and the symbolic number, all at once. For months, the decision hung in the air, and in November of 2013, the committee that decides these things ruled. They studied the drawings, listened to the designers, and determined that the mast was permanent and integral enough to the design to count as a spire. One World Trade Center kept its full height of 1,776 feet and kept the crown as the tallest building in the Western Hemisphere. The $20 million the owners had saved by stripping off the cover did not, in the end, cost them the title. But for a while, it very nearly did. A National Landmarks official height decided in a committee room over a budget line. Right at the top of that spire sits a beacon, a crown of stainless steel that lights the sky over Manhattan. It was built by a metal shop in Brooklyn, formed from dozens of triangular stainless panels over a steel frame, assembled near the top of the tower before being raised the final stretch into position. Its light became a new landmark for Lower Manhattan, visible for miles. A fixed star at the top of the tallest building in the hemisphere. Now we promised earlier that we would come back to the safety story and tell it straight, because we do not pretend a story is cleaner than it is. Through the structural construction, the lead contractor reported no deaths and no major injuries. A genuine achievement on a build this size and this dangerous. But over the full span of the entire project, across all the connected work on the site, the Port Authority confirmed 2 work-related deaths, both reported to the safety authorities. And a New York newspaper, after reviewing records, reported that dozens of worker injuries on the wider project had not been properly reported, and that for a stretch, the injury rate ran above the national average. The Port Authority pushed back and said safety rules were strictly enforced. We will not tell you which side is right, because the honest answer is that the record is mixed. But set it against the 60 lives lost on the original towers, and you can see in those numbers how much construction had changed. The goal was no longer just to build the tower. It was to build it and bring the men home. And by the hardest measure there is, this build came far closer to that than the one before it. There was one more enemy this tower had to survive, and it did not come from the design or the budget. It came from the sea. In late October of 2012, as the tower was climbing, a great storm drove the Hudson River straight into the site. Floodwaters poured down into the lowest levels, and the basements filled with an estimated 15 to 30 feet of water. The governor said the river was pouring in with such force that they feared for the structure of the pit itself. To fight it, the crews ran roughly 100 temporary pumps alongside 30 permanent ones, with more than 100 workers watching the water around the clock. The flood destroyed the tower's fuel cells, causing millions in damage. But the building survived. The water was pushed back out, and the work went on. Then, on the 3rd of November, 2014, after 8 years of construction, One World Trade Center opened. The first major tenant, a large publishing company, began moving in, carting thousands of crates from Midtown. On that first day, only a small fraction of its employees started work, the first people to fill the floors that so many hands had raised. The most expensive office building in the world at the time, at around $3.9 billion, was alive. So let us stand back and look at what changed across those decades, because that is the story we came to tell. 2 builds on the same footprint, 40 years apart. On the old towers, 8 Australian cranes. On the new one, 2 from the very same company. On the old towers, ordinary concrete and open steel walked by fearless men. On the new one, concrete stronger than rock, pumped higher than it had ever gone in the Americas, poured at night and chilled with ice, and a frame wrapped in netting to keep its builders alive. On the old towers, 60 lives lost. On the new one, a build engineered so that number would never come again. The tools got stronger, the methods got smarter, and the men who walked the steel sometimes came from the very same families. If you want to see where this story truly began, our film on the machines that built the original World Trade Center is the other half of this one, and the two belong together. One World Trade Center stands today at 1,776 feet, the tallest building in the Western Hemisphere, built on the footprint of what was lost, anchored to the same bedrock. sharing the same Great Wall that survived. It is a monument, yes, but it is also one of the most remarkable construction achievements of our age, dear, raised by machines and by men who deserve to be remembered for the work. Thank you for watching and for helping us keep the history of how things are built alive. If you are not yet subscribed, join us, and we will see you on the next one.